In the previous unit, we discussed a little bit about use cases. Mostly what we were talking about, though, in the previous unit, well, other than an introduction to systems analysis and design, we also discussed this whole idea of gathering user requirements for a system for which we're doing a design. I talked about different techniques to do that. So hopefully at this point in the process, you would have gathered all this information about what the users need. And now we have to somehow express those uses as use cases. So this is how we diagram, model, and define all the things that we know that our system needs to do. So anything that our system is going to do, we're going to talk about in a use case. And this is from a very high level. So first, let's define what a use case is exactly. We talked about this briefly before, but a use case is an activity that the system performs, usually in response to a request by a user. So our book, the textbook, talks a lot about users and how they would use the system. One thing I do want to mention, though, is that the use case does not always have to be something that a user does. It can also be things that external systems do. So it's important to remember that sometimes you have external systems that are going to use your system. So you have to make sure you can document and diagram those things as well. So use cases define functional requirements, so things that our system needs to do. Analysts decompose the system in a set of use cases, and we call this functional decomposition. So what is decomposition? Well, we start out with this idea that we're going to have a system that does something. And maybe that something is we're going to develop a system for account management. Well, account management is a very high level, very vague description. We have to decompose that into all the different things that one has to do in the process of managing an account, all the different things that we expect our system to be able to do. And you'll see some examples of this. We're going to talk about two techniques for decomposing the system into a set of use cases. Those two techniques are going to be user goal technique and the event decomposition technique. The event decomposition technique is probably the more popular, the better way to do it, but we'll talk about user goal as well, which works for smaller projects. As you create these use cases, we're going to use a verb, noun, label. I'll talk more about that in just a second. But first, let's talk about the user goal technique, which is the first technique, which is not very comprehensive, but I think it's good for us to talk about it. So step number one is you identify all the possible users for the new system. So all the people that might be using the system. And as I said earlier, users may be more than just people. Users could also be software or external systems that are going to be using our system. Once we've identified all the users, our next step is going to be to classify all those users into functional roles. We're going to talk about this idea of classification in much more detail in the next unit. Classification is a really important concept for systems analysis and design, especially object-oriented systems analysis and design. But here we're talking about just classifying exactly what types of users we have. And there's a couple different ways that we can do that. So example, you can have shipping, marketing, sales, so basically classifying by what they do. So functional roles is what those users actually do. The other way to classify users is into their organizational level, so where they are in the organization. So for example, operations, executive, professional. So for example, I work in the medical industry, and an example of classifying users would be by their functional roles would be doctor, nurse, lab tech, things like that. And then in the organizational levels, you might have cardiology, ophthalmology, radiology, and so forth, all the ologies and so forth and so on. So you can see there's kind of two ways to classify. But if somebody's a doctor, they're a doctor regardless of whether they work in cardiology or radiology or ER and so forth and so on. So you can kind of come up with these two different methods to classify people. And once you do that, the next step is to to find the list of specific goals for each one of those user types. So you want to start with their current goals, so what they have to do to get their job done, and then imagine some new functionality that would add value to the system. So it's really kind of brainstorming. And again, we're going to use this verb-noun phrasing. What exactly does that mean? If you remember back from grammar school, we start with a verb, we end with a noun. It's basically verb-noun phrasing. So add a customer, or update order, or produce report. So doing something is basically a verb-noun phrase. All of our use cases should have a label that is a verb-noun phrase. Step 5, we're going to create the use case list organized by user type. So So we're going to think, okay, for each one of my users, here's all the stuff that they were expecting to be able to do with the system. Step number 6 is to look for duplicate use cases and resolve any inconsistencies. So maybe things that certain users can do that other users can also do that maybe you think they shouldn't be able to do, things like that, or maybe things that, if you've got two different people doing the same task or the same thing, but it's really, identical, try to reduce those into one use case. We'll talk more about that later on. And step 7, identify where different types of users need the same use cases, which I really just kind of described, jumped a little ahead there. The final step in the user goal technique is to review all the use cases with each type of user and the stakeholders. Make sure you got it right. Make sure that you properly defined and codified all the things that they're going to need to do with the system. So a more comprehensive technique, and a little more complete, is the event decomposition technique. So this is a bit more formal than the user goal technique. User goal technique is good for a smaller system where you can just kind of sit and brainstorm with the users. What do you need to do with the system? I've certainly done it with smaller systems that I've developed. If there's a system where there's only 1 or 2 users, user goal technique hands down is easier. But any larger system or more complicated systems would require something a little more structured like the event decomposition technique. So first, we're going to identify the events that occur to which the system must respond. And then for each event, we're going to name a use case, again, with the verb-noun phrasing that describes what the system does and when the event occurs. There's different types of events. So we have to talk about what is an event. So an event is something that occurs at some time and can be described. And it also is something that happens that has to be remembered by the system, right? So if you think about it, adding a new account is something that has to be remembered by the system because you have to remember the account details. So that's one way you can think about an event. It's something the system has to keep track of. Let's take a look at events and use cases in a little bit more detail. So if you think about it, if I have a customer, you might say the customer pays their bill, or a customer makes a charge, or a customer changes their address. This is something a user might tell you. Notice the phrasing here is a little different than what we want for a use case. So we can convert this into something a little more appropriate. We'll talk about that in a second. Inside our system, the user might tell you, and this is without somebody kicking off any event, they might tell you that it's time to send late notices, or at some point we send statements, at some point the system produces reports. So this is all stuff that happens automatically inside the system, and it's triggered by either some event or some time inside or within the system. So this isn't a user interacting with the system. So we have 2 different types of events here. We have what we call external events, which are around our system. And then inside our system, we can have temporal or state events, which we're going to talk about in more detail in the next slide. But before we talk about that, let's convert the phrasing that our stakeholders and our users use into an actual use case label. So for example, record payment or process charge, update customer, send notices, produce statements, produce reports. So again, that's our verb-noun phrasing. Makes it very simple and succinct so we know exactly what that use case is. There are 3 types of events that we define in the event decomposition technique. I already talked about 2 of these. We have the external event, which is an event that occurs outside the system. Usually it's initiated by an external agent or actor. We'll talk about more what actors are later on, but the important thing is something outside of our system is initiating that event. And like I said before, this doesn't always have to be a person. This could also be other systems. We're finding more and more in the real world that a lot of our systems are interacting with other systems through things like APIs and web services and things like that. So in modern systems, you have a lot of initiation of events happening from other systems, but we still consider those an external event. They're not a state or a temporal event. It's something that happens external to our system that triggers things to happen within our system. So those are all external events. By and large, most of them are in most systems, of course. Most of that stuff is still an actual person that's using the system, so it's kind of easy to see how that happens. A temporal event is an event that occurs as a result of reaching a point in time. So something happens because we reached a point in time. That point in time could be static. It could be every day at noon, this happens. It could be a clock. It could be a timer. After 27 minutes, this happens. Or after 1 hour after an order is placed, this happens. Something like that. So those are temporal events. And we have state events, which is an event that occurs when something happens inside the system that triggers some process. So sometimes we can have triggers that change because of states. And we'll talk in a lot more detail about states later on in this semester. We'll talk about state machines and things like that, and how we can diagram and model that stuff. But for the most part, we're worried about external and temporal events in our use cases. So here's an external event checklist. So an external agent or actor wants something resulting in a transaction. So for example, customer buys a product. Or an external actor wants some information. Customer wants to know their product details. Or an external data changed and needs to be updated. Customer has a new address or a new phone number. So these are all external events. Management wants some information. Sales manager wants to update on production plans or something like that. So these are all examples of external events. Temporal events could be things like internal outputs needed at points in time. So management reports, operational reports, internal statements and documents. External outputs needed at points in time. So statements, status reports, bills, reminders, all that kind of stuff that happens at a certain point in time would be our temporal events. So how do we find these events? Well, if you're talking to a user, they might tell you that the customer thinks about getting a new shirt. And then they drive to the mall. And when they get to the mall, they go to Sears and they try on a shirt. And then they might go to Walmart, which is us or something like that. They try on the shirt at Walmart and then decide to buy it. So they buy the shirt. So if somebody gave you this chain of events, if they said, the customer thinks about getting this shirt, drives to the mall, of all this stuff that they talk about, and these are all important things to most people who run a business, right? If you're running a retail store, it's important for you to think about this entire process, about your customer thinking about buying the product and how they go about getting to your store and then browsing the store and then finally purchasing that product. But for our system, the only thing here that's important, the only thing we have to worry about is the customer buying the shirt, because that's the first time that our customer or our external actor interacts with our system. Or actually, in this case, the cashier is what's interacting with our system. But either way, and that's, of course, something we have to realize here, is that the actor in this case really is the cashier and not that customer. But this is how you have to think about these events. So you wouldn't diagram any of this other stuff that happens. It's really important. And, this is a very simple example, but in complex systems, sometimes you kind of have to get to the bottom of, okay, what's the actual action that is interfacing or interacting with the system? So sometimes it's important to dig down into that. So tracing a sequence of events is also important in use case. So for an example, customer requests a catalog. Then the customer wants to check item availability. Then the customer places an order. Then the customer changes or cancels an order. Then the customer can check their order status, can update their account, and finally return the item if they don't like it. So here, somebody could be telling us a story of, here's what my customer can do in the life cycle of being a customer. And that can help us identify use cases. The last thing about our event decomposition technique is it employs this concept of perfect technology assumption. And what do we mean by that? That means don't worry about functions that should be built into the system because of limits in technology and people. We're going to wait until the design phase to do all that stuff. So in our analysis phase, we don't want to think about things like logging in, or changing a password, or changing preferences for their account, handling errors, doing backups, anything that has to do with security, like minimum password length and things like that. Or when, a temporal event might be, you might say, I have a temporal event that the user has to change their password after 90 days. We're not going to worry about that stuff in this phase. And we will talk about that in the design phase, but it's important not to get bogged down in these technical details. So the perfect technology assumption means don't worry about the technology, worry about the process, worry about what our system actually has to do. Anything that every system does, we can forget about that stuff. Every system has logins. Every system has passwords. Every system has user preferences. All these systems have these things, and you don't want to clutter up your use cases with all the minutia of managing the system. So when a user is looking at these use cases, they don't have to worry about, they don't get bogged down in the details about logging in and changing the password. If you think about it, when a user is describing what they're going to do with a system or how they use a system, they're thinking mostly about their functional requirements, which is good. That's what we want. But if you start throwing things in that have to do with the minutia of running the system, those are things that they don't understand very well, right? So they're not familiar with the process for logging in. This is all new stuff for them. So they were going to get bogged down in that and try to think about all the stuff that they don't know and say, okay, well, I don't know what this login thing is. How is this going to work? Well, why waste time discussing that in the analysis phase when we could do that later on in the design phase? That's something we know has to be done anyway. So, and this is important, I think, no matter how you're doing the use cases, is use the perfect technology assumption so we don't get bogged down in these details. Let's break this down into the steps. There are 7 steps in our process, in our event decomposition process. So the first step is consider the external events in the system environment that require a response from the system by using the checklist shown in Figure 3-3. This is obviously from the textbook. So in Figures 3-3, they have a little checklist that you can use to consider the external events that require a response from the system. So these are basically identifying all the things that people are going to do with our system. For each external event, identify the name. Identify and name the use case. And remember, we're going to use that verb-noun phrasing for each name. Then we're going to consider temporal events, things that happen because of something at a certain time. And again, there's a checklist in your textbook in Figure 3-4 that you can use to help you brainstorm those. For each temporal event, just like our external events, we're going to identify and name each use case with our verb-noun phrasing. Consider the state events the system might respond to, especially if it's a real-time system. So, for example, things happening within the system that might change the state of something that might trigger some kind of event. We'll talk more about that later on. And then again, for each state event, identify and name the use case. And the 7th and final step is when the events and use cases are defined, check to see if they are required by using the perfect technology assumption. So don't include any events that are the minutia of operating your system, like log in, log out, changing your password, restoring a database, all this stuff that we can put in later that we know our system's going to have anyway. So anything that deals with the flaws of technology and people that we have to design around, we're going to ignore that stuff for now and pretend that we have perfect technology. So we just talked about 2 techniques, user goal and event decomposition. Why is event decomposition better? I kept saying that was a better technique. Well, first, it's broader than user goal. And it can capture temporal and state events as well as external events. So user goal generally only captures the external events, whereas the event decomposition can also capture our temporal and state events. It can help decompose at the right level of analysis or elementary business process. Your book talks a little bit more about what an EBP is. It's a fundamental business process performed by one person in one place in response to a business event. So it's kind of a business term. But business is kind of important to us in systems analysis. It uses perfect technology assumption to make sure that functions that support the user's work are identified. In other words, what supports what the users do as opposed to what the system needs to do. We'll worry about the system later on. A final consideration for when you're developing these use cases is to think about CRUD, which stands for Create, Report, Update, and Delete. Usually you'll hear people talk about CRUD in the context of database design. So insert, select, update, and delete, for example, is the equivalent of CRUD in the database world, and usually talk about how we're going to do that in databases. It's a technique to validate and refine or cross-check your use cases. So if you think about it, everything that we have to keep track of in our system, and again, we'll talk more about things in our system next. So right now we're talking about how people use the system. In the next unit, we talk about the things in our system that we have to keep track of. But we have to, typically, people are going to need to create things, read and report on things, update things, and delete things. We need to make sure that we've accounted for all those pieces of functionality for each use case. It's not primarily identifying use cases. So at this point, when we get to a CRUD analysis, we've already identified all the use cases. Now we're going to make sure that they resolve against this concept of CRUD, and I'll show you how to do that in just a second. So for each domain class, verify there are use cases for CRUD. So what is a domain class? It's a fancy way of saying a type of user that will interact with the system. So when you hear the term domain class, we're just talking about types of users. Your book uses that over and over again. So for example, I can make a table like so. And my domain class, maybe my first one, is going to be customer. So I have a customer domain class. In other words, a customer is a type of user that can interact with my system. That's a domain class. CRUD is create, read, report, update, and delete. So I'm going to list those 4. And then for each one of those 4, I'm going to find the use case that I came up with for that domain class. So I have a use case for delete customer. I have a use case for looking up a customer, producing a customer report, processing account adjustment, update customer account to archive, which is equivalent to delete. So I'm listing all those use cases, and this is a good way to identify that I have some way to do all of the basic functionality for each domain class or for each type of user. So that is a domain class table. You'll see that in the textbook. When they talk about a domain class table, this is what they're talking about. So some steps for CRUD. 1, identify all the data entities or domain classes involved in the new system. We're going to talk more about that in Unit 3. So in Unit 3, we're going to discuss domain classes in much more detail on the things that our system has to work with. For each type of data entity or domain class, verify that a use case has been identified that creates a new instance, updates existing instance, reads or reports values of instances, and deletes or archives an instance. If a needed use case has been overlooked, this is the time to add it. So that's the whole point in this exercise, is to make sure we didn't miss anything. And 4, with integrated application, make sure it's clear which application is responsible for adding and maintaining the data. So if you have more than one application within a system, which is very common, by the way. Most of our modern systems consist of many different application pieces. So it's important to know which application is going to be doing each of these different steps. Once we've defined all of our use cases, so we've brainstormed, we used one of our techniques, either user goal or event decomposition, to brainstorm all of our use cases. We've verified them with our users. We verified with CRUD that we have everything that we need. Now we have to do use case descriptions. This is where we take a list of all of our use cases and we describe the basic steps to complete each use case. So as an example, create a customer account. My description would be user enters new customer account data, the system assigns account number, creates a customer record, and creates an account record. So that would be a description of creating a customer account. Looking up a customer, user enters customer account number, the system retrieves and displays the customer number and account data. Maybe another one is process account adjustment, which would be user entering an order number, then the system retrieving the customer and order data, and then the actor enters adjustment amount and the system creates a transaction record for the adjustment. So I'm basically describing all of my use cases. So the use case label itself is very simple, but there's a lot of things underneath that, under the hood, that we have to describe. And that's what a use case description is going to do. So one of our first deliverables is going to be a list of all the use cases for our system and a description of each use case, an in-depth description of each one. It only has to be a couple sentences, a paragraph at the most. If you find yourself describing a use case with more than a paragraph, chances are you've got more than one use case hidden within that one use case, and you need to decompose a little bit further. Once we've listed all of our use cases, now we're going to make a diagram, or what we call a model, right? The official term is model. So now we're going to model that use case. So a use case diagram is the UML model used to graphically show use cases and the relationships to actors, so how actors relate to use cases. So there's that term actor again. We're going to talk about that in just a second, but in UML, which is the Unified Modeling Language, this is a standard for diagrams and for terminology for developing information systems, and that's what we focus on in this course. So in this, in the UML, you have an actor. An actor is the name for the end user. Not just an end user, though. When we talk about an actor in UML, not only can that be a user, it can also be other systems. It can be external systems. Anything outside our system that's going to initiate some action within our system, something that we have to handle from an external source, is an actor. We have an automation boundary. An automation, and again, these are UML terms. So actor is a UML term. Automation boundary is a UML term. It's the boundary between the computerized portion of the application and the users who operate the application. So again, the automation boundary, everything inside the automation boundary is the system that we're designing. Everything outside the automation boundary are the actors that are interfacing with our system. So here's an example of how to draw a use case. You start with a stick figure. The stick figure is the actor. And I know it seems real simple and kind of kindergarten, but that's all it is. So when you draw a use case, you're going to start with a stick figure for each one of your actors. So you identified a list of all your actors. And again, it doesn't have to be just people. And you're going to draw these little stick figures on your diagram, and that's going to be your actors. Each one of those actors is going to have connecting lines that show how they participate in the use cases. So it's going to connect to a use case. Your use cases are going to be written in little ovals inside your use case diagram. So for all those use cases we identified, you're going to have an oval that has the use case label. And then finally, you get your automation boundary, which shows the actual system. So you have a box. Inside your box, you've got all these ovals. All the ovals are the things that the system is going to do. Outside that box, or outside your system, is your people that are interacting with the system. So use case diagramming steps. First, we identify all the stakeholders and users who would benefit by seeing a use case diagram. Determine what each stakeholder or user needs to review in a use case diagram for each subsystem or each type of user for use cases that are of interest. So you don't always have to do a use case diagram for all of the use cases, but it's helpful for people to see how they're going to use the system. For each potential communication need, select the use cases and actors to show and draw the use case diagram. We talk about this later on, but there are software packages that can help you draw these diagrams. Rational Rows, Microsoft Visio. There's a whole bunch of open source ones out there, like Star UML is an older one, but there's plenty of newer ones, even ones you can go online and do for free to draw these diagrams. But I'll do a separate video on those. Carefully name each use case diagram and note how and when the diagram should be used to review the use cases with stakeholders and users. So you're basically trying to define what exactly do I need to diagram. You don't have to diagram all the use cases. I think it's good practice to diagram most of the use cases. In most projects, we tend to do that to give everybody some visibility in who is going to be interacting with the system and how. So everybody has an understanding of how they interact with the system. So as an example, in your textbook, they have this running case, the RMO case, or something Mountain Outfitters. I forget what the R stands for, but RMO is a clothing company that sells stuff online. We've talked about them before. So they've got customers, customer service, store representatives, and managers. So how are they going to interact with our system? So your customer and the customer service and the store rep can all manage accounts. The customer can connect to a friend, accept a friend, view their RMO points, send messages. The manager can adjust points, but notice the customer cannot do that. The customer can send points to other users and receive points from other users, so they can gift each other points. So this is an example. Now notice, this is not the entire system. The only thing we've diagrammed here is a certain part of the system. This is the customer account relationship management system. So this is just where our customer can go in and play with their mountain bucks, they called it in the textbook, or the RMO point system, like their frequent flyer miles, more or less. So this is just one part of the system. So here's another example. We have our customer, and if they're going to purchase products, the customer needs to be able to search, view products, accessories, fill their cart, empty their cart, check out. Oh, I have empty cart there twice. Sorry about that. So these, again, are things that our customer is going to do with the system. And again, this is one part of the system. This might be the shopping cart system or the online ordering system or something like that. Notice here that I don't have a customer service rep, a store rep, or a manager because they don't interface with this part of the system unless they happen to be taking on the role of a customer, which is entirely possible, right? A customer service rep might use all this stuff, but they would be doing that as a customer, not necessarily as a customer service representative. One other final concept that we need to talk about is this idea that you can include things. So, for example, when my customer empties their cart, that could include searching for new stuff for their cart, viewing products that are in the cart, and viewing accessories that they can add to their cart. So you can have an includes relationship. Notice here that my customer is using all four of these, but the customer starts by using the empty cart function, which can then, or the empty cart use case, that use case also includes the search, view product, and accessories use case. So this is a more accurate way of describing how the customer is going to interact with the system, because they're not necessarily going to directly say, I want to view a product at this point. They might say, I want to empty my cart, but at the same time, they're going to be viewing products, searching, and viewing the accessories for those products. By the way, I believe that should say view cart, not empty cart. So it would be viewing their cart. So when they're viewing their shopping cart, they can search for more products, view the products that are in their cart, and view accessories that they can add for products that are in their cart. And that's it. So that's basically how use cases work. It's a fairly simple concept. I know it looks, kind of Sesame Street here with the, with our, I'll go back a few slides for our basic example. Again, it looks kind of kindergarten with our stick figures, but this is all it is. This is basically a use case, and you'd be surprised how much insight this can give you into a system when you're doing diagramming. So, again, our first step for analysis is going to be developing our use cases. We're going to define each of those use cases that are inside that automation boundary. We have to define all those, and I gave you a couple different techniques to do that. There was the user goal technique, the event decomposition technique, which is much more comprehensive and follows a little bit more structure. We can verify that we've identified everything using the CRUD technique, and hopefully, maybe drum up some additional use cases required by our system. And then we're going to list all those use cases with a brief description, and finally put them in a diagram and show how actors are going to interface with those various pieces. And that's it. So if you have any questions, please let me know.